Let's take a look at a basic elasticity problem, and then we'll solve this prompt for both total revenue test as well as the midpoint method. We'll start off with the total revenue test because it's the more simplistic to do. Alright, so the prompt says that a goods price falls from $10 to $9, and then the quantity demanded increases from 100 to 150 units. So without even speculating about the elasticity, let's just move on and set up the problem. First thing that I recommend that you do is set up your prices and quantities in a table. That way you don't get lost as to where you're at, and you make sure that the right price gets associated with the right quantity. So what we're going to do here is we know that the good went from $10 to $9. So we have 10, that's our first price, and our second price is $9. And we know that the quantity demanded increased from 100 to 150 units. A good thing to do at this time is just take a quick look and make sure that what you're drawing here doesn't violate the law of demand. So we do have a falling price and a rising quantity demanded, so it looks like we're on the right track. The next thing that we're going to do is calculate the total revenue. Remember from previous video or class that the total revenue is just equal to price times the quantity. So here the total revenue would be $1,000. So at a price of $10 selling 100 units, our total revenue is $1,000. If we drop the price to $9 and we sell 150 units, our total revenue is going to be $1,350. So all we have to do at this point now is take a quick look at this and look at that relationship between the price and the total revenue. So we see as we go from 10 to 9, that means our price has fallen. If we look at our total revenue from 1,000 to 1,350, that's gone up. And as we talked about before, when the price and the total revenue go in opposite directions, then the good is elastic. Just think of it as elastic, meaning they can stretch. Now let's look at that same problem, but instead we'll solve it using the midpoint method. So I put the midpoint method on the paper here, and so we see, as we talked about before, Q2 minus Q1 and all that extra stuff. Just real quick separate that off. Alright, so another way of stating this would just simply be the percentage change in the quantity divided by the percentage change in the price. So keeping that in mind, we can maybe take a little bit of shortcut here in order to solve this. Now, one way you could do this problem would be to take the Q1 and Q2 and substitute them in and solve the whole thing. I'm going to show you an easier way to kind of make this process go a little bit faster. Alright, so as we talked about before, the difference between the two prices divided by the midpoint between the two in this case the quantities. So let's take a look at the two quantities. Our quantities are 100 and 150. So the difference between the two is going to be 50. And we're going to divide that by the midpoint between the two. That's 125. On the bottom of the equation, we are going to have the difference between the two prices, which is $1. It would actually be negative $1 if we follow that direction correctly, and divide that by the midpoint in between the two prices, which is $9.50. Alright, having gone through that first step and simplified the problem, all we need to do now is finish up the math. 50 divided by 125 is going to leave us with 0.4. And negative $1 divided by 950 is going to leave us with negative 0.105. When you divide this out again, your final answer is going to be negative 3.8. Just some basic notes on this answer. Your answer is always going to be negative, but you can kind of just forget about the negative sign. The main issue here is, are we between 0 and 1, or negative 1? Are we exactly equal to 1 or greater than? In this case, we're farther away from 0 than 1, and that's really the important part about it. So the elasticity is 3.8, meaning there's pretty strong elasticity here in this case, meaning that essentially the change in quantity is about 3.8 times bigger than the percentage change in price. And if we come back to our original prompt and look at that, it should be pretty obvious. Here we go from $10 down to 9. It's a $1 change in price, and the quantity jumps from 100 all the way up to 150 units. So that also kind of confirms the idea that this is an elastic good.